To this I-21 video tutorial. In this video we are going to teach you how you can connect to the data acquisition software GDA. So once you are connected to the node machine and you are successfully connected to I-21, in the top right corner you can identify this diamond symbol in here. You can click on here, you can choose data acquisition, start GDA client. This will show you this log panel of GDA, which is just running a set of tests. You will get all these errors at the beginning. This is normal. It's just like any motor that is not currently connected to the beamline, then it will run as an error, but you shouldn't worry about that. This doesn't have any impact. Then one should try to choose what is the folder for your experiment. And then you will be connected to the GDA. So this is the layout, the standard layout for the rigs display. So here, this is the Python console. So we use Java-based Python. So here in this console you can type any type of command to run individually, like to do any type of scan. Your data folder should appear up here, and it will be linked to the number of your proposal. So inside of there it will appear all your data files, all the folders, all is in there. Here you have the live controls of the beamline, that they show you the information about all the motors and all the different positions. You can, with your mouse, try to drag it up so that you can see better all the values that they are in there. You can also resize every type of window, try to make it more comfortable for you to see it in the best way that you can. So here in the live controls you have information about the ring current, the gap, the polarization, the energy. This M4C1 corresponds to the I0 used for normalization of your data. S5B1 gap is the size of the exit slits. This is the temperature, that is sample temperature. And here you have different values of different motors, like XYZ, theta, chi, phi, and 5 TTH that corresponds to the position of our collecting mirror, that should correspond to the arm position when performing rigs. This is the position of the diff TTH, which is a photodiode we have inside of the main vessel for doing measurements of absorption or diffraction when needed, position of the spectrometer arm, and different positions of the spherical rotating micrometer, and the angle of the detector. So all these values are going to be changing here, so whenever something is moving, as you see in this moment, you will be seeing moving here, and you can keep track of the motions and how your experiment is running. This is the display of the CCD detector, which is the angle detector. If you click on it and then you choose histogram up here, then you go to image settings. You can choose what is your favorite type of false color map. In my case I have used jet, but you can use whatever you prefer, gray, any other type of false color map. You just need to choose it in here, and then you can resize the histogram, including the values in here. Once you are running your experiment, we have a live rigs spectrum view, which is shown here. So if you resize in here, then it will resize the intensity. Once we start performing the experiment, and we can give you information about the energy dispersion and the slope for your experiment, then you will need to introduce the values in here, and by introducing the offset that corresponds to the position in pixels of the vertical line, then everything would look more similar to a real Richter spectra, so that you could get a more clear view of what is going on. This is not really like proper values, but as an example, just to show, if we include the value of a dispersion, and include this type of thing, and then we click in update, right? And then you see that it looks more sensible. So here we know that this is about so we can do the same here. We can yes, and then it gets close to the zero. You just need to tweak it using the right value so that it corresponds to the zero, and like this you can get a view of what is the data that you're measuring. Of course, this is a carbon tape signal, and then using the carbon tape is much simpler to try to align the zero perfectly. Another important thing is down here, it tells you what is the scan that is running, if a script is running. Here it says which is the user that is connected, and this is that the button is not held. This is important when operating remotely. So if you double click in here, it will open this button manager and it will show you everyone that is connected to the Beamline at the moment, and with which machine they are connected and the visit. Now, the person that holds the button is the one that is controlling the experiment. So we need to discuss between users and local contact who is going to be handling what and how we are going to like release the button. So you need to request the button if you want to do something by yourself. Afterwards, when you're finished, please release it. We can take the button from you if we need to do something. And as I said, only the person holding the button is the one controlling the GDA and the one able to launch macros. In the synoptics here, you get information again about the current, the ID gap, the refill, the energy, and that everything is open. If you have a scan that is running and you want to interact it, please click this stop button here. Do not click this panic button, because this button corresponds to stop all the motors at the beamline in case that there's some sort of risk, like either crashing or something serious is happening. If you click in this, it will stop every single motor at the beamline, and it will take quite some time for everything to come back, and probably we will need to realign several things. So please remember, if you want to stop a running command, click this stop button, which is in here in the shell. The next thing that you will need to do is how you can look at some data or how you can get information. So by default, when it opens, you will only have rigs. You can choose the different type of views by going here to like open perspective, and then you can choose the different perspectives in here that you want to see. So if you open like data browsing, like in here, we have any given scan, you can just choose the different plots where it appears, like choosing here by the right. But what is very interesting and I wanted to show you is down here you have this option that is tree. If you get in tree, you click in this entry and then you go to before scan, you have all the information in the metadata of all the motors at the beamline, that it can be very useful if you want to check what the parameters were for one particular scan or another. So you have the value of theta, you have x, you have y, z. All these values of the motors are saved in here in the tree under entry 1. Another useful perspective would be to use scripts in which you can go and try to like open a script. So we have some sort of templates, like this one is a template for like a Q scan, and then it's written in Python, as I said, which is Java-based Python. And the important thing to remember about that is because it's Java-based, you cannot use NumPy. But there are ways around the most common commands in NumPy that we can use Java commands for that, and we have written some different templates of the most common macros that you will need to run, and we will share this with you. So what we will do is that we will create a folder for your experiment, that it will be here in scripts, user, it will be like SR3, then it will be users, the run in which you are, and then we will create a folder with the number of your experiment, and then you will be able to save there all your macros that you are running, and this will belong to you, and we will copy you some of the templates, and we will help you modify them at the beginning to get your experiment started. For running a macro, this is very simple. You need to just click on the macro that you want to run, make sure that it's saved. If it has a modification on it, it will appear with an asterisk. You save it. Once you have saved it, just to run it, you just click this button, run. This will run the macro. It will show it here that it's running a script, and then you will see all the different commands running into this console here. Then you can go back to the rigs view, and then you can see all the data that is appearing, and how the data is acquiring as the macro is running, and how the motors, everything is moving with respect to the positions that you have denoted in your macro.